And now in this lecture we'll answer two questions. In the first question, we find out the area of this green triangle, triangle ABC. And in the second question, we find out the length of this line segment AP is equals to x. We have to find out the value of x. So we start with the first question. In the drawing we have quadrilateral AQ PCB. This is quadrilateral AQ PCB. We know that AQ equals to AC. We also know that this is angle PQC, that is the right angle. This is angle QPC, that is equals to 60 degrees in its size. This is angle ABC, this is also equals to 60 degrees in its size. Side AB equals to 5 units in its length. This is line segment PC, is equals to 4 units in its length. Again, our task was to find out the area of this green triangle, triangle ABC. So first of all, from point A, we go perpendicular on QC. Again, from point A, we go perpendicular on QC. And we find the touching point of the perpendicular from point A and QC. This point is point M. So really, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. Triangle AQC, this is triangle AQC, this is an associated triangle because side AQ equals to side AC. QC is the base of the associated triangle, triangle AQC. So from point A, we go perpendicular to the base QC. We have the rule that says the perpendicular to the base of an associated triangle bisect the base. Again, the perpendicular to the base of an associated triangle bisect the base. So the associated triangle, triangle AQC, according to the rule that I mentioned, the perpendicular AM bisect the base QC. Again, the perpendicular AM bisect the base QC. That is to say, QM equals to MC. So if we define the length of MC as A, then QM must be also equal to A because they are equal to each other according to the rule that I mentioned. In the next step, we will extend the perpendicular AM by straight line until it touches side PC. And again, we extended the perpendicular AM by straight line until it touches side PC. We define the touching point of the extended perpendicular AM with side PC. This point is point M. So actually, we know that AM is a perpendicular, it is absolutely a straight line. And when we extended the straight line AM by straight line, the result is AN. So AN is also a straight line. So if we focus on the right side of the straight line AM, if we focus on the right side of the straight line AM at point M, here the sum of the angles must be equal to 180 degrees according to rule 3. Rule 3 says that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the right side of AN at point M? We have this angle that is the right angle plus this missing angle. In total, they must be equal to 180 degrees according to 3. Therefore, this third missing angle must be equal to 90 degrees in its size. Actually, in the right triangle QPC, this angle equals to 60 degrees, this angle equals to 90 degrees, 60 degrees plus 90 degrees, it is 150 degrees. 150 degrees plus this missing angle, in total it must be equal to 180 degrees, according to rule that the sum of the angles in any triangle is equal to 180 degrees, and therefore this third missing angle must be equal to 30 degrees in its size. Likewise, in the small right triangle NMC, this angle equals to 30 degrees, this angle equals to 90 degrees, and therefore 30 degrees plus 90 degrees is 120 degrees, therefore this third missing angle must be equal to 60 degrees in its size.